So hi everyone, this is Kirti again, and I'm here with my next video which will demonstrate how easily you can tackle problems from mathematics section in the CLAT entrance examination. Now typically these problems on the face of it, they come across as very time taking and challenging at times, but if you use the right techniques and if you use the right approach to solve these problems, you will increasingly see that it's very easy and uh, very fast to solve these problems. Now I'm for the purpose of this particular video, I'm using 4 problems which were actually asked in the CAT entrance examination, the CLAT examinations 2015, and I will tackle each of those problems individually just to show you how easy it is to solve these problems. So now let's have a look at this particular problem, wherein you can see that this is a simple summation of Bodmer's kind of a problem which has been given. Now if you try to calculate this as per the numbers given in the problem here, then it will become a time consuming and a challenging problem for you. But if you're smart enough to understand this relation between these 3 different numbers which have been used at different places in the problem, you will see that this can be represented as x, this as 2x, and this is 3x, and that is how I have represented these numbers here for the purpose of simplification. So now suddenly, from being a number intensive problem, what we have done is that we have converted this problem into a simple algebraic equation which is far easier to solve. And once you break this down, you can easily see that the sum is coming to 0. And if you are able to identify this, which should not take more than 5 seconds, then writing the problem in this particular form and solving it will take another 10 to 15 seconds. So basically, even if you are slow, you should be able to crack it within 20 to 25 seconds, which is a pretty good speed. So now we'll move on to our second problem, which again on the face of it comes across as a time intensive or time consuming problem. So the problem is simple. Basically it comes from the number system space, and a lot of questions from this particular area have also been asked in your management entrance examinations like CAT and XAT, etc. Okay, so you see that you have to find out the sum of 16 cube, 17 cube, 18 cube and 19 cube, and then you've got to divide that number by 70 in order to identify what the remainder will be. Now the point to be noted here, and that's quite an important and a very intriguing, interesting point, is that any number, if it has to be divided by 70, and if it has to be completely divisible, must have a 0 at its units digit place. Yeah, so if this is the number, let's say 7870, now if you divide this number by 70, so it should be completely divisible by it. So this 0 and this 0 should go. So that's very important, and then you have to check whether the remainder of the problem, that is divisible by 7 or not. So now we have broken down the problem in 2 stages, where you have to check divisibility by 7 and you have to 10, and you have to check the divisibility by 7 per se. Yeah, so for this particular problem, we'll see that 16 cube here, if you look at the last digit only of 16 cube, it will be 6. Last digit of 17 cube, it will be 3. Last digit of 18 cube, it will be 2, and last digit of 19 cube, it will be 9. You add up all of these, it comes out equal to be 20. So one thing is certain, that the number is divisible by 10. The other part wherein we say that if the number is divisible by 7 or not. So it's very simple again. What we will do is that we will try and see what is the divisibility, what is the remainder when we individually divide all these numbers by 7. Okay. So for 16 cube, again, if you let's say 16 cube divided by 7, what is the remainder here? That is my problem statement. Okay, so what I do is that I find out the remainder when we divide 16 by 7, and that comes equal to 2. Alright, since there is a cube here, so I do 2 cube and I get remainder as 8. Eventually, if you are getting your remainder as 8 and your divisor is 7, then your ultimate remainder will be 1. So 1 is the remainder for this particular part. Coming back to 17 cube. Yeah, so 17 cube by 7, what is the remainder? Yeah, So again 17 by 7, you can easily say that the remainder is 3. Yeah, and 3 into 3 into 3 is 27, divided by 7, the remainder becomes 6. So again 6 plus 7, it gets completely divided by 7. So you can say that for these two numbers the sum is divisible by 7 itself. Now coming on to this part, which is 18 cube and 19 cube. Again it's quite the same process that we will follow. 18 cube divided by 7, we have to find out the remainder. 18 when divided by 7 leaves a remainder of 4, which 3 times in cube of 4 is nothing but 64, and again you can say that the final remainder is 1. Similarly for 19 cube divided by 7, the remainder is, in this case, 525. When you divide this by 7, your ultimate remainder will come out to be, so let me figure this out, 55, and so that comes out to be 6. So again 6 plus 1 7, 6 plus 1 7, which is a sum total of 14 divided by 7 completely. So your remainder essentially is 0. Therefore we have just proven that the number gets divided by 7 as well as 10, and hence it will be divisible by 70, and therefore this option of 0 is the right answer. Now we'll move on to the next problem that I have taken, and again it's a permutation and combination problem. A lot of students get into formula mugging and all of that, and that gets very difficult. Permutation combination as a concept is a very simple concept. It's basically counting in a particular fashion, okay, and arranging those countings. So we will again use some basic principles here. Yeah, so let us first see what the problem is. Okay, so the problem says that there is a man and he has got 4 boys as his friends, and he has got 5 girls as his friends. So a total of 9, and that is how we are representing it here. Okay, now he says that he wants to invite his friends in a particular fashion so that there need to be exactly 3 girls. Every time he invites people, there need to be 3 girls. So now the first thing is that if there have to be 3 girls compulsorily, okay, on the guest list, that means the total number of guests will vary from 3 to 9. Yeah. If we are ensuring this, then we can say that the number of girls have to be 3 or more. But here the problem says that the number of girls have to be exactly 3. Now in this particular case, let us say if I fix the number of girls, so I say that G1, G2 and G3, these are the 3 girls, or the 3 spots. Let's not name the girls at this point of time. So we'll only say that we will have 3 girls in the invitation. So again, very quickly, we have 3 spots taken by girls, G, G, G. Now, since it says that there has to be exactly 3 girls, therefore, the possible combinations with boys will be, if I say girls and boys, so the possible combination will be 3 girls, 0 boys, 3 girls, 1 boy, 3 girls, 2 boys, 3 girls, 3 boys, 3 girls, 4 boys. So these are the only possibilities in which he will invite people so as to meet this criteria of inviting only 3 girls. Yeah. Now, so what I have done is that I have simply tried to count, and I have not used any formula here. Yeah. And it's not rocket science, it's very easy. 3, 0, 3, 1, 3, 2, 3, 3, 3, 4. So these are the 5 possible combinations. Now if you have to pick up 3 girls out of 5, a total of 5 girls here, you know that the number which you will get, the ways in which you will choose these three girls will be 5 combination 3. So this number is always fixed. You know in what are the ways to choose the girls. Yeah. So which is 5 factorial divided by 3 factorial divided by 2 factorial, which will be equal to 5 into 4 into 3 into 2. So there are 10 ways to pick up girls out of this. Yeah. Now let's get on to boys. If you have to choose 4 boys out of 4, you know that there is only one possible way of doing it. If you have to pick up 3 boys out of 4, so it will be 4C3, which is nothing but which is 4, again 4C2, which will be 6. If you are choosing 0 boys, so there is just one way of choosing 0 boys, and if you are choosing 1 boy out of these 4, so there are again 4C1, which will be equal to, so I am doing this calculation for you, otherwise these are easy ones. Yeah. So once we are done with this particular basic counting, we know that these are the particular ways in which I will choose my girls. These are my combinations in which I will invite people. Yeah. And these are the ways in which I will choose my boys. So after that it becomes a problem of simple addition. Talking about that, let me show you how easy it is. So it is 10 into 1, which is 10, 10 into 4 is 40, 60, again 40, and again 10. This is 100, 160. So there is no confusion whatsoever, is that 160 is your answer. Now you might have gotten into various kinds of formula, etc. And to be honest, if you ask me, I've never ever remembered any formula in permutation and combination. So this is the only method that I use, and it's an extremely simple first fundamental, first principle methods that you can solve to, that you can use to solve problems from PNC. It also breaks down the problem very easily. It gives you exact clarity of what the problem is asking you, and the chances of you making any mistakes is minimal.